tell me, based on your knowledge of indices is like index. Remember index notation you learn in Sec 1? It's just plural or singular, right? But it all means the power. What are the rules governing the power of whatever numbers you have? So if a square, I ask you to multiply by a5, what do you think I will get?
It's 8 to the power of 7.
A what? A square means what? A times A. So what do you think is A5? A times itself 5 times. Correct? So if I were to write it as a combined index notation, how should I write it? A to the power of 7. So that's rule number 1 for you. If you are multiplying the same base number numerous times, you will add up the power. So this is law number 1. If you have a raised to the power of m, multiply by a raised to the power of n, you basically sum the power up. So that's rule number 1. So actually you know already, you have learned this. Just that they state it explicitly for you. If you see two same base number, you just add up the power. Okay, what about division? What about division? What do you think the answer will be? Subtract. Okay, but because a to the power of 5 means a multiply itself 5 times, right? Okay, let me use red. A multiply itself 5 times. And we are so used to this rather than division. Right? And then you realize that they cancel out. So in other words, you are left with a square. And this is showing to you that actually it seems to be like a subtraction. So the second law that we are learning is that when we divide them, we subtract the power. So that's the second law of indices. Okay, yes.
What if it's a to the power of 3?
Later below we have. Okay? So, next one. What do you think this will result in? A square, B square? This one is cube. A cube, B cube. Because this means AB multiply itself 3 times. So, if I were to write it out, this is A times B. Why suddenly got ruler? Okay, so this one is A times B, A times B, A times B. So actually you have A cube, B cube. I never write the times in between is because it is understood that this means A cube times B cube. So mathematically you don't have to write the multiply there. Okay, so this is the other rule that we have. Is that if you raise this to power n, both of them should get the same power n. So that's rule number 3. Okay, the sequence don't matter, but it just means that. Okay, so same thing. If I have half and I ask you to raise it to power 4, it just means I'm multiplying half 4 times. So in other words, it's like 1, I raise it to power 4. 2, I also raise it to power 4. So I get my answer as 1 over 16. So
instead of let's say 2, it's like a, we do like a to the power of.
correct. So if I have a fraction and I raise it to power n, both numerator and denominator should get the same power as well. So all these are just quite obvious to you, but they state it out in laws so that you know that you can apply to any case. Okay, so that's the 4th law already. So angry. Okay, if I'm using this law, what will it end up as? A to the power of what? If I'm using this law on top, the same rule is division, right? What do I do to the power? Minus. So it ends up being A to the power of what? 0. But you also know that when I have A over A, they cancel one another out and you have 1. So the next rule, although it's not very obvious, they tell you that if you raise anything to power 0, it's equivalent to 1. Okay, so that's rule number 5. So all these things actually you know. If you write everything out explicitly, you know. Okay, but they just want to summarize the general case for you. Okay, what about this one? If I also use this rule, what do I get? Negative? Okay, the power is negative 2. But if I were to do it this way, Alexa, Rishan, Marius, find your focus while laughing. Okay, so what do I have? I cross out the 3. Okay, and then actually it's the equivalent of A squared at the denominator. So they are saying you can actually change the form. Okay, if your A square is at the denominator, you can always bring it up as a numerator and change the power to negative. Same thing, if it's a negative power, I can always bring it down and make it positive. Just like if I tell you 2 to the power of negative 5, it is equivalent to 1 over 25, which is 1 over 32. This is something that is friendlier for you than using this. Because in your mind, you don't know what is its value. But if you write it this way, you can calculate very quickly. So this is another way that you can change its form. So this is rule number 6 for you. You can always bring the power down and make it positive. So that is the 6th law. Okay? So there's also other laws on square roots. So do you all remember how does square root work? If I square root a square, what do I get? Just cancel out. Then what if it's a A4? A2. What if it's a A5? So remember, they are telling you in this rule that if, wait, let me use the correct pen color. Okay, so what they are trying to tell you is square root is the equivalent of power half. So if you have any power that is attached to A and you take a square root means raise it to power half. That's why all these numbers you see here, they were half. Okay, because square root means you halve the power. So you have subtly learned this when you were in Sec 1. Where you do your index notation and then you find your perfect square and then find the square root. Okay, Sec 1 you learn this. So that is, there's more, I think there's a total of 9 rules. We have 7 here. The last 2 we will use it later. So now using this 1, 2, 3, 4, 5, 6, 7 rules, let's do all the questions together. Let's look at page 2 now. You should be able to do them. Okay, turn to page 2. They say simplify A5 times A7. Then you go and write down what you think the answer is. Okay, I'm leaving the page here because someone's still copying, right? You all can go and do example 1 first. Yes. You copy. Okay, if you are a bit faster, move to second page and try the examples there. Okay, remember, find your own kind. If it's numbers, numbers deal with numbers. Letters deal with letters. So usually you will enjoy E-math. Not that you won't enjoy A, but E should be like a just mental exercise. All done with this page? Anyone still copying? No, Okay, so this one, quick answer. Yes, because you add these two up. That's all. Okay, then next, number multiply by number 12. P square and P6, P8. Q1 and Q8. That's all. Okay, O-level question got like that one. Don't be scared when you see this. Or like, don't be worried like must have something hidden between the line. It's just like that. Okay, then when it's division, so become Q6. That's all. Okay, numbers deal with numbers. 30 divided by 6, 5. R9 divided by R8, R1, right? And then S10 and S3, S7. Okay, so power 1 no need to write. Just leave your answer like this. Okay, so deal with the right term. All the like terms, you deal with the like terms. Let's look at this one. Remember just now we say, if it's A, B, N, each of them should get the power N. Right, this law. So same thing here, there's only this one term. So it means this times itself 5 times. So what are you essentially doing? You are multiplying the power with power. So when it's separated by a bracket, you are actually multiplying the two powers. So it's actually 9 times 5. So B what? 45. Or you can see as 9 plus 9 plus 9 plus 9 plus 9. Okay? So whenever you have separation by a bracket, power multiplied by power. Okay, what about these two? What is the first thing you can get from here? C what? C 48. Okay, this is C 30. And then if it's division, what do you do to the power? Minus. That's all. Okay, so all the rules must be at the back of your mind. But if you ever forget, you can always go and do the very layman way. 48. Then you imagine what you will do if you have 30 at the bottom, then the cancellation. And remind yourself it is subtraction. Okay, you can always go back to this and remind yourself what's the rule if you are ever confused. Okay, this one, we have spoke about it. If it's a fraction, both of them gets the power. If it's a product, both of them gets the power. So how do I use it here? How do I use it here? P what? P8. Q what? Okay, same thing. P what? P18. Q 6. Then you deal with the next rule. Now it's multiply. What do you do to these two power? You add. So it's 26. Same thing for this. Q 26. So it's just all the rules. Have it at the back of your mind. Not difficult, right? Can or easier said. Okay, Here's the exciting part. You know O-level will never let you off so easily, right? It will slowly get more complicated. So try what?
Like change it to like PQ and then bracket
But it's different though. There's a 3 here, there's a 1 here. So unless you want to factorize the 3 out. Yeah. So if it confuses you, you can always go and write this thing 6 times.
it's like
Oh, you mean you want to write like that?
Yeah.
Can. Okay, if you want to simplify your answer like that, you can. Okay, but make sure it's correct lah. If you go and do extra step and then it's wrong, you get minus marks. Okay, but this is good enough. But if you want to do the extra step, it is also fine. It's just that you go and factorize it only. Okay, can ah? Showing tantrum, is it? Okay, ready? Okay, go and try example 8. It's slightly more complicated, but do it step by step. This is the first example. Okay, this one. Which one you not done copying, is it? Okay, Raven. What do you get for this first term? 12? Is this 12?
no, it's 3 to the power.
3 to the power of 4. What is 3 to the power of 4? 81. So this one is a common mistake. Many of you will write 12, but actually it's 3 to the power of 4. Okay, 3 gets the power 4. Same thing. Power gets the power. So 5 times 4. So A is 20. Okay, what about Raj? B what?
B the power of 12.
Correct. So multiply, power multiply with power. There's a power 1 here. Just that we don't write it there. So it's 1 times 4. Okay, same thing. Everything else, you can leave it there first. This is a negative 9. Negative is like the surname of the number. It must always follow it wherever it goes. So negative 9, when I raise it to power 2, what do I get? Also 81. So be careful about that. The negative is with the 9. When you square it, the negative is gone. Okay, same thing. What do you get here? Amishi? What do I get for the A? A6. Shu Huai, what do I get for the B? Which question? Example 8. What is your A? What is your B? Yes. Okay, then the rest is just keep, change, flip. Right? You keep this. Then you change. Then you flip. Okay, so now the idea is this. All the numerator, you see them as 1 because it's multiply. All the denominator, you see them as 1. So you can do your cancellation now. 81 and 81 cancels out. B12 and B12 cancels out. I have 20 A's on top, 6A at the bottom. What am I left with? 14 on top, right? This is gone. So my final answer is just A14. That's it. Did I miss out something? No, right?
No.
Where got negative? This one, remember, when you negative 9 square, it becomes 81. No more negative.
Oh, you have to put bracket.
Yes. Remember, the negative sign is attached to the number like the surname. Don't remove it.
Okay.
Okay? Quite friendly, right? No?
It's just yes.
Okay, this one 9. Oh no, you're still here? Or you're done? We have 2 minutes. Raven just rolled his eye where I say we have 2 minutes. Okay, what is 11 to the power of 0? Anything to the power of 0 is 1. And then when you have a negative power, bring it down. So actually this is 1 whole minus 1 9. So it's 8 9. Oh, why? Huh? Also you missed. Go and watch the video. Okay, this one same thing. You could choose to add up first since it's multiply. Right? Negative 9 plus 6 is negative 3. And then now you bring it down. And then you get 1 over 125. So it's all about the rules. If you remember the rules very well, you work less hard. Okay, what about this one? Separated by a bracket, power multiply power. What do I get for 2? Okay, then what about the second one? Okay, so when it's division, what do I do to the power? Minus. So you end up having 2 to the power of negative 3. All these can use calculator. Minus negative 2 become plus. Remember? Minus 45 minus negative 42. It ends up as plus 42.
But you have to bracket the square.
Bracket the what?
The square.
Why do I need to bracket the square? There's a bracket. When there's a negative, usually we put a bracket. But if you don't want, it's fine. Okay, so you end up having this. Okay, there's still one more period later. Okay, so we will stop here. But I hope you find it refreshing. Or we might even finish no, not the whole notes, part of the indices. Great. Okay, see you later. Brief. Okay, remember, if you have a fraction, both of them should get the same power. This is the law that governs fraction, okay, with a power. So if I look at this, what should I get? What? 7 negative 1. 6 also negative 1. Okay, but we don't like to have negative power, right? So actually, isn't this the same as, right? And then I can write this as 1 over 7. Okay, I can write this as 1 over 6. Okay, correct? Because the rule says if I have a negative power, I can bring it down and make the power positive. So you do your keep change flip. And then you end up having 6, 7. Yeah, we totally planned for this. Okay. So actually the shortcut is this. From here, right? If you ever have a negative power and you change it into a positive 1. Okay, wait. If you change it to a positive 1, can you see this? From negative 1, you change to positive 1. They say that the shortcut is actually flipping the fraction inside. So you could actually use this. So in other words, they say that if I have a over b to the power of negative n, I can flip the fraction inside and then change the power to positive. This is a shortcut that you can use. So this is a shortcut that they don't really write it officially anywhere, but you can use it freely for solving the question. Okay, so you might want to put it down somewhere to remind yourself. If you have a negative power and you want to change it to positive, just flip the fraction inside. Okay, so with that, let us try example 5. Okay, write down the shortcut, Saud. Okay, that means you leave your whatever answer in terms of something to the power of what? Instead of writing a times a times a times a, you write a times to a to the power of 4. That's index notation. Okay, let's do 5. Not yet. Waiting. Okay, so here, this one, same thing. If you have a negative power, you can change it to a positive power by flipping the fraction inside. Can you see negative become positive? And then you flip the fraction inside. Technically, if they ask you to evaluate, you can straight away press the calculator and find the answer. But if it's 2 marks, you need to show me working. If it's 1 mark, just press calculator. Yes. Okay, if you flip it this way, this is the method mark. Or if you know that both of them gets the same power, either one, you will get the mark. And then final answer is just 49. But however, if the question is 1 mark and they say evaluate, you can just press calculator. No need to work so hard. Why? You all like always having a debate behind the class, huh? Okay, Hashid, give me the answer for part A. When it's separated by a bracket, what do you do to the power? Okay, so what do you get? Okay, but if you look at the question, they say they want your index notation to be positive. Means all the power must be positive. So I need to change the negative one to positive. So what should I get?
Flip it to 1 over n to the power.
Okay, so this one, that means I need to change it to 1 over n 15. And then I have a m here. Okay? So you combine it into 1, basically it's just m20 over n15. So this is positive index notation. Means you wouldn't see a negative power anywhere. Okay, let's do part B. Raven, what do I get? What do I get for my answer for P and for Q?
It's plus 6 plus minus 6 equals 0.
Okay, so P0, Q,
-5.
okay. But can I simplify it? What is P0?
That is Q -1.
Sorry?
P is 1, so it just
So this one is just 1. Anything raised to the power of 0 is 1. And then this one I change to.
1 over Q.
So actually my answer is just 1 over Q to the power of 5. Okay, nice. Ashville. This and this is, what is 5 divided by 15? 1/3. Okay, then the x, what do I get? -7? No. Divide means you subtract the power, right? Yes, Vishan, why? P6 plus -6, gone. Yeah, when you add it, it's gone. Okay, then what about this? What do I get? -1. Okay, then what is your y? 2. Okay, so I want to simplify such that I don't have negative power, right? So the 1/3 and then x to the power of -1, you can write it as 1/x, and then this is just y squared. So all the numerator, all the denominator, so this is your final answer. Okay, of course you can just show me everything in one step. If you can see this directly, just give me this. -5 because -2 plus -3. Bracket means multiply. Okay, so part B, you all need to look at it like they are asking you to multiply these two. Okay, because they put a bracket there to imply multiply. Okay, I think example 7, we don't really need to prove it anymore. We have shown it in the previous example just now. It is just a rule that you can use. Explain B again, Ken. Okay, so let's look at B. This is the example. So this is the question that they gave you. So when they put bracket, I can change it to multiply. So that's the first thing. Okay, next one is, if it's multiply, we basically add up the power. So P is 6 plus -6, and Q is -2 plus -3. So you end up having P0 and Q -5. Okay, so that's how you change it to this form and get this. Okay, so all your final answer, double check. This one, and this one. Yes. If they never say express your answer in positive index notation, you could have left your answer like this and it's done. Okay, you can also leave your answer as this and it's done. Okay, you can also leave your answer as this and it is done. No need to bring the x down and so on. So it depends on the question. Only if they say positive index notation, then you need to change. But if you OCD, right, you want to change, it is also correct. Is the flip, is it?
Yeah.
Okay, this one.
We substitute the value.
Not really. You apply the formula first. Both of them get this power. Raj, what do you like? Fish?
I say this law is very nice.
Oh, okay. So A to the power of -n divide by B to the power of -n. I will write them both in the positive index form. And then I do a keep change flip. So I keep this, and then I change, and then I flip this. Then I end up having Bn, An, which I know is this. So this is a subtle rule that if you want to make the power positive, you can flip the fraction inside. This person, it's like y'all go out on a date, right? With whoever, right? You keep asking for the time. Like, what time is it now? Why you want to go home, is it? Horrible. Study what? What's there is there already. 2 more minutes, it won't squeeze anything inside. No, I want to finish this one. Yes. Which one? Expansion? From here, huh? Also can. Okay? Don't worry, it's all inside you already. I can't. I don't remember anything. Serangoon, when I was in... Why? What happened? Okay, but I was the top student there. Just saying. Okay, so let's move on to the last rule, please. I just finished the last rule, and then I don't think I have time left. Okay, now I move on. Okay, this one. Shh. Just now we say if we have a square root, it means power half. Okay, if we have a cube root, what do you think it is? Power 1/3. So if it's the 4th root, then it's power 1/4. So if it's the nth root, then it's power 1/n. So that's what they are trying to tell you. So when you see fractional power, fractional indices, you know it involves roots. Okay? And if you ever see a fraction where the numerator is not 1, you can always make it 1 by separating them as 1/n times m. Okay? So it's as good as telling me that this is the nth root of a, and then you subject it to power m. So it's just a different way of solving the problem. Okay, so like this one, like 16, we want to deal with the 4th root of 16 first. So we take out the 5, separate them out because we know it's multiply anyway, right? So I separate them out. And if you go and find the 4th root of 16, 9. This is the last 2. Okay? So actually the 4th root of 16, if you press the calculator, it is 4th root. Okay, I don't write like that. Okay, maybe to help you, right? 16 is 2 to the power of 4. They are the same. 16 is 2 to the power of 4. And then there's a 1/4 over there. So what do you think you end off with? What do you think you end off with? Just 2, right? So 2 to the power of 5. Final answer? 32. Not square root, it's the 4th root. Okay, one more time. Okay, first thing first, I don't like to deal with 5/4. So I will split them up as this first. Okay? Why? Because I know 16 can be changed to 2 to the power of 4. They are the same. 2 times 2 times 2 times 2 makes 16. Okay, and then with that, I still have my 1/4 there. I still have my 5 there. So I realized that I could actually simplify this, and the quarter is gone. So I end up having 2 to the power of 5 remaining, which is 32. Okay, then some of you will say, why do I need to do this? I just press calculator, they give me 32. Correct, but the question will say evaluate without the use of calculator. Although you can still find the final answer, but you need to show me the intermediate working to get your working mark.
So we have to factorize.
Yes. No, they will give you a number that you can square. Yes. You can use the 8. 16 1/4 root 8. Yeah, you can change to this also, which is 2. It's the same. It's like I do this one first. Also can. Okay, let's try one more time. Shh. In everything we do, you need to practice a few similar ones to have stickiness. So first thing first, this is a negative power. How do I make the power positive and flip? So this is 125 over 1. If I flip it, it is 1 over 125. Okay, so I've just made the power positive, and then I flip the fraction inside. Okay, so this is using the rule. Next step, both of them should get the power 4 over 3. So both of them get the power. 1 to the power of anything is just 1. Okay, so I can simplify this as 1. So now the problem is just my 125. I don't like to have a numerator that is not 1. So I will split the 4 out and put the 1/3 inside, so that I can do a cube root of 125. Okay, so what is the cube root of 125? Just 5, because 125 is essentially 5 cubed. If you wanted the power, you get 5. So that's why cube root of 125 is just 5. This part here is just 5. And then I have a power 4 outside. So what is 5 to the power of 4? This one can use calculator. 6 to 5, is it? 6 to 5. That's it. Okay? So the idea is to split the fractional indices such that the numerator must be 1. Then you can go and take the nth root of whatever number you want. Okay? Can the last one is not difficult. What do you get? Yes. 1 to the power of anything is just 1. You can 1 to the power of 1 million, still 1. No matter how many times you multiply your 1, it's still going to get 1. Okay? Okay, what do I get from the first bracket? This one? A to the power of what? 8 over 3. Right? And then what do I do next? What do I do next to the 2 powers? Add them up. So it's just A cubed. Yes. 4A. 2/3 times 4. You get A over 3. No, this is just like an, right? You multiply by m. So it's an times m. You multiply the two power. We only handle the power. The a don't get anything. Yeah. Okay, remember the power belongs to a. This power belongs to a. I am subjecting this to itself 4 times. This is like this. Okay, that's why I have 2/3 plus 2/3 plus 2/3 plus 2/3. So it's 4 times 2/3. Can. Can. Okay, example 4, 5, 6. Can you do as homework? No. Tomorrow got WA? Yeah. Tomorrow got? 3 example cannot do. I will give you all ang pao next week. In the ang pao, there will be a math problem. Yes? 8 over 3 plus 1 over 3. You add the power up. So you get 9 over 3, which is 3. Remember, AM times AN, you add the power. Okay, so the 9 laws must be at the back of your mind. Then it will be easy. Okay. 9. Okay, so because Jia En is very shocked, so Jia En, can you tell me what do you get for the first one? Negative what? Why negative 6?
I get negative 6.
Negative? 3 over 2?
Negative 6 over 1 is negative 6 over 4.
When it's divide, what do you do to the power? So what do you get? 11, what? 2 and 3/4, right? So 11 over 4. So you do this, 3/4 minus negative 2 become plus 2. Okay, what about this one? Because it's 2 whole and 3/4, we don't write our power in mixed number. It will usually be improper. So it's better to write like this than 2 and 3/4. Don't write 2.75. We rarely see decimals power in the final answer. Not that it's wrong, but it's just weird to see it. Okay, what about this one, Rishan? Why? Don't want to do homework, right? Do classwork. Negative half. Okay? But because question never say you must leave in positive index, you can just leave like that. No need to work extra.
If you were positive index, you would 1 over
Half. Okay? Next one. Next one. Okay, Marius, can you simplify all for me? Waiting. Four over 3x. Remember, 4 is power 1. So, every power must get the power 1/3. 4 to the power of what? No. 1/3. 4 must get the 1/3 also. Okay, now what about this one? Okay, I change the color. This one. Minus 1/9, correct. Because minus 1/3 times 1/3. Okay, what about this one? Y is 1/6. So remember, when it's separated by a bracket, you multiply the powers together. Okay, next person, Jeff. What do you get here? Wait. Let me finish this one.
We need to do social.
Okay, wait. Let me finish this one. Jeff, what is this? 32 to the power of what? Okay, what is x? Negative 2/3. Last one. This one. Negative 1/6. Okay, then you go and continue from there. We will leave it here. Run for your recess. Just go. Okay, thank you class. Oh, really running? Why left for food? Digestion it. If not, take photo, ask ChatGPT to summarize for you the main point. Yeah.
Consultation today.
Yeah, today in the class. So if you have questions, just bring the question. Yep.